Welcome to absolute value parent functions. What we're going to look at today is we're going to see what graph, key attributes, and characteristics are unique to absolute value functions. Hopefully, you'll be able to spot an absolute value function compared to other functions thrown at you and be able to list all those key attributes it has that make it what it is. So the first thing we're going to do is we're going to fill in this table and we're going to graph the absolute value function. This is what it says right here. We're going to graph f of x, that's like y equals the absolute value of x. I chose some random x values here, -2 to 2, because they're going to be near 0 on my graph. And what I'm going to do is I'm going to take the absolute value of them and find the y value, because remember, f of x means y. You could put these in a graph in your graphing calculator and make a table and a graph out of that. That is perfectly fine. In fact, I probably will go around and show each of you guys how to do that in class. So, absolute value. Remember the absolute value function. If you remember back to when you first saw it, it just makes things positive. It's the distance something is from 0. So -2, if you make him positive, becomes +2. The absolute value of -1 is +1. The absolute value of 0 is 0. The absolute value of 1 is 1. And the absolute value of 2 is 2. Now remember, these are, as I said earlier, they are points. So you can think of them as x, comma, y, or in this case, -2, comma 2. Where would -2 be? Well, on the x-axis at -2 and up to +2. On the y, you put a dot, -2, 2. Now I'm going to plot the next one, -1, 1, over to -1 and up to +1. Then the next one, 0, 0, so at 0, 0, or the origin. 1, 1, over to +1, up to +1. And the last one, 2, 2, over to +2, up to +2. And what I'm going to do is I'm going to connect those dots with a nice, beautiful line. And remember, these things go forever and ever and ever, so we put arrows at the ends. That's the absolute value function. Basically, he is V-shaped, where he starts right here at the tip on the origin of his little vertex there and goes up forever. There he is again. Now remember some of our key attributes. We're going to be looking at domain and range. That's the x and y values. The x and y intercepts. That's the points where you cross through the x and y axis. And one more is reflectional symmetry. That's where we're going to look at the mirror images over a line of reflection. We're going to see the symmetry. Is it across what line? Here's our absolute value parent function. Remember, I told you in the last video, I like to put arrows at the end if the computer doesn't put them. And we're going to start off with domain and range. Now, I told you in the last video, I like interval notation, and that is what I'm going to use. So domain, start at the left. Ooh, it's an arrow. Go to the right. Ooh, it's an arrow. That's all real numbers. But remember, this is the negative side of the x's. Positive side of the x's. So, and remember, arrows mean infinity, so negative infinity to positive infinity. Now I'm going to do the range, bottom to top, and I'm going to use interval notation for it as well. So cropping, it looks like I can get that right there at 0. Up at the top, it's arrows again. So on the y, remember, down here's the negatives, up here's the positives, and it looks like he starts right here at 0 and goes up forever and ever. So he starts at 0 remember starting at, and if it's something that's not an arrow, you can put a bracket comma, forever. There we go. Now our x and our y intercepts. Well, that's where he crosses the x-axis. I'm going to look at the x-axis. That's this one. And it looks like our graph is right there at 0, 0. Now my y-intercept, I'm going to mess with him now. Y goes up and down. Again, right there at 0, 0. Now, the harder one is reflectional symmetry, because that's been a long time since you talked about symmetry. But you notice this is a V shape. Yep, see, it's a nice, beautiful V. So if I was to chop the V right down the center and make it the same on both sides, where I'd chop it at? Right down the center. And it's the same on both sides of it. That line right there is the y-axis. So again, we're going to look at these key attributes. An absolute value parent function, which is V-shaped, will always have a domain of negative to positive infinity. It will always have a range from 0 to infinity because he starts at 0 and goes up forever. His x and y-intercepts are at 0 because that's where his little vertex is. And his reflectional symmetry, that means he's going to be reflecting over the y-axis. Let's try it with this function. Now, he is not V-shaped, so he is not an absolute value. If you remember, he's a parabola. It means he's a quadratic function. But you should be still able to find domain, range, x, y-intercept, and even its symmetry. Now, I went ahead and put the arrows down there for you. Give him a try in your interactive notebook. So it means you go to the left side of the page, do a little sketch of him, and write down his domain, range, x, y-intercepts, and symmetry. And hopefully you get these answers. Have a good day.